Good morning, children. Now let us discuss some important formulas in this chapter, what we have completed so far. These formulas are very important for us. Let us start the formulas. You have seen that you can see your display. First formula, torque can be written as I into alpha. I means moment of inertia. It is also taken as in the case of linear velocity or linear mass can be considered. I stand for mass. Here I stands for moment of inertia. Alpha is acceleration. Here angular acceleration. Torque is equal to R into F sin theta. Torque acts along the z-axis, force acts along the y-axis, and R acts along the x-axis. As I have told you in the class about taking the door, we have to consider R into F sin theta. Theta is the angle between R and F. Now if you see the third formula, torque can be written as, if you take sin theta, theta is 90 degrees, R cross F. It is a cross product. Now if you take the kinetic energy, half mv square, that is similar to half I omega square. So mass is I and velocity is omega square. Angular velocity is angular velocity. There you will call it as linear velocity, here angular velocity. Kinetic energy is equal to half I omega square. Keep remember, it is similar to half mv v square. Now kinetic energy can also be written as, you split that omega square, omega into omega. So I omega into omega. I into omega is linear momentum. Sorry, it is angular momentum. So kinetic energy is equal to half angular momentum, angular velocity. Product of angular momentum into angular velocity is kinetic energy half L omega. Now coming to the formula number 9, L is equal to I omega. L should be, L means angular momentum is equal to I omega, angular velocity into moment of inertia. L is equal to m r square omega. This is similar to that of the formula number 10. If you observe that L is equal to m v r. M into v is momentum, linear momentum. So L is equal to linear momentum into r. Ninth formula if you see, L is equal to p into r. 10th formula if you see, L is equal to P means mass into velocity. P means mass into velocity. P stands for linear momentum. L stands for angular momentum. So P should be written as M into V into R. Now we know that V is equal to R omega. Formula number 12 if you see, V is equal to R omega. That you have to substitute in the place of formula number 10. L is equal to M. V means R omega. So formula number 11, L is equal to M into R omega into R. So R into R is R square. That comes to the formula number 8. L is equal to M R square omega. Only just a change of one word will change the entire formula. Okay. Just okay. V means R omega. We can take V is equal to R omega. If you replace it for the formula number 12, V is equal to R omega, that can be replaced to the formula number 8, formula number 10. Then if you see formula number 13, alpha is equal to omega final minus omega initial by delta t. That is alpha is equal to A is equal to V minus U by T, similar to that of A is equal to V minus U by T. So alpha is equal to angular velocity final minus angular velocity initial by delta t. That can be taken as 14th formula, alpha is equal to d square theta by dt square. In terms of displacement it is written. D square theta by dt square is the angular displacement. Rate of angular displacement is angular velocity. Rate of change of angular velocity is angular acceleration. Okay, keep remember. Now if you see 15th one, centripetal acceleration. The acceleration acting toward the center is called centripetal acceleration. For a body revolving in a circular path, the body is being balanced by the centripetal acceleration. Centripetal acceleration towards the center is equal to v square by r. Here r is the radius and v is the linear speed along the tangent direction. So centripetal acceleration can also be written as v is equal to r omega. As you see, the formula number 12 should be replaced. V square means R omega square. So R square omega square. Here R is capital letter. R get cancelled. So one R will be left over in the numerator. So R omega square. Centripetal acceleration is equal to R omega square. Now centripetal acceleration can also be written as 2 pi by t. Omega value is what? 2 pi by t square into R. Omega means 2 pi by t. Square is there. So omega square into R. That is called centripetal acceleration. Now we know that omega is equal to 19th formula. Omega is equal to 2 pi n. N stands for number of revolutions per second. We have to consider per second. If it is given in minutes, divided by 60. So number of revolutions per second should be considered. Omega means 2 pi t or 2 pi n. N stands for revolutions per second. Now coming to the formula number 20, I is equal to mr square. Moment of inertia is the product of mass of the body and square of the distance. Moment of inertia is the product of mass of the body and the square of the distance. 21st formula, it is perpendicular axis theorem. Iz, axis of rotation, moment of inertia about an axis, that is axis of rotation, it is passing through the lamina from the center of mass. Ix plus Iy. So this moment of inertia along the x-axis and moment of inertia along the y-axis, they are on the lamina. Keep remember, they are on the lamina, over the lamina. And Iz is always passing through the center of mass. It is perpendicular to the both Ix and Iy. So these three axes, moment of inertia about the x-axis, y-axis and z-axis, these three are in mutual perpendicular to each other. That is called perpendicular axis theorem. Now parallel axis theorem, the moment of inertia is passing through the center of mass and about and parallel axis at any point on the plane lamina about an axis is equal to the moment of inertia from the center of mass plus mass of the body, entire mass of the body, and the distance between the axis of the body and the center of mass. Axis of the body and the center of mass distance is a square. So I about an axis is equal to the moment of inertia about the center of mass plus total mass of the body and the perpendicular distance between the I axis plus moment of inertia about the center of mass. Now 23rd formula, radius of gyration. We know that for a rotating rigid body about an axis, the masses are at different distance. They are not uniformly distributed. They are distributed at different distances from the axis of rotation with different radii. So if you wanted to join all those particle distances of smaller masses, their average mean velocity should be considered. Their average masses, if you consider them, we are calling it as a radius of gyration. So their radius will not be uniform. In order to maintain the uniform for a single body, that is a rigid body, so we need to go for radius of gyration. So the radius of gyration gives the information about the ratio of the moment of inertia to the total mass of the body under the square root. So square of I by m is the radius of gyration. Now 28th formula, if you take the radial acceleration, the acceleration along the radius is the square of the centripetal acceleration plus tangential acceleration. You know that a particle which is moving in a circular path, it has two accelerations, along the tangent acceleration and along the centripetal acceleration. So AC is towards the center and AT is, in the case of AC, is towards the linear velocity. So if you consider, like in the case of a right angle triangle, AC square is equal to AB square plus BC square. Similarly here, we can take the acceleration towards the center and acceleration along the linear side. So if you join these two, we will have the hypotenuse as AC square. So AC can be taken as the radial acceleration. It is the sum of the square of the two accelerations along the centripetal side and along the tangential side. That is AR is equal to under root of AC square plus AT square. Now coming to the 29th one, shifting the center of mass of a uniform plate. As we have discussed in the earlier class, if you consider a uniform plate, from that a small circle piece of a plate is been cut in the form of a circle and it is been taken out. So the radius of that plate is B, smaller plate is B and larger plate is capital R. Now the distance from the center of mass, shift in the center of mass side is S towards the left side, and the shift in the center of mass of that particular particle in the small circular plate can be taken as A. So left side is distance is S, right side distance radius is A. Now the smaller circle of radius B should be considered. For the uniform thin plate, we are considering the shift in the center of mass, that is the S side is equal to B square A by R square minus B square. In the case of solid sphere, shift in the center of mass of a solid sphere can be taken as, instead of square you write cube. So B cube A by R cube minus B cube. So you should keep remember this formula. Now you know that a particle on a rigid body can be considered from x1 distance and x2 y1 distance and z1 distances. So if you wanted to calculate the particle of mass m1 and m2, they are at the distance of x1 and x2, can be considered from the x center of mass as m1 x1 plus m2 x2 by m1 plus m2. Similarly, y can be considered. Similarly, z can also be considered. Now if you are taking the position vector of those particles on the rigid body from the coordinate system, from their position vectors as r1, r2, r3, so on. So the center of mass from the position vector can be taken as m1 r1 plus m2 r2 by m1 plus m2. This is for two masses which are having r1 r2 as the position vectors. Now the torque, we know that torque is equal to r into f. It is the product of the radius into force. The force is acting on the y-axis and the radius vector is along the x-axis. From the hinges of a door, when you apply the force on the clamp, the distance, the x-axis distance and the y-axis distance is r into f. In between them, if you consider the angle, it is rf sin theta. So it is a vector product, scalar product, it is a vector product of a cross product, r into f. Now when you consider from the r1 point, when you are considering from the r1 point, so you have to subtract the r2 minus r1. When you are considering from the R2 point, we will take R1 minus R2. So torque acting about an point R2 can be considered as R is equal to the other point R1 minus R2. When we are considering from R1 means R2 minus R1. When we are considering from R2 means R1 minus R2. By keeping this in the mind, we can calculate the determinant of the torque can be considered as ijk, closing the I value, take the z value and k value, closing the middle line, then we can go for I into k. Closing the last column, we can go for I into j. In the determinant method, we can calculate the torque. So if this angle is given, we have to go with r into f sin theta. Now coming to that here, 24th one, if you observe the 24th one, v is equal to under root of 2 m g l sin theta. So here 2 m g l sin theta, g is missing, you have to replace that. 24th one is v is equal to under root of 2 m g l sin theta. Here 2 m g h, actually it should be 2 m g h. H means in the case of a wedge or an inclined plane which is at an angle theta, sin theta is equal to opposite side h by l. Opposite side h by l, sin theta is equal to h by l. From that if you consider h is equal to l sin theta. So here 2 mg h means l sin theta by m plus I by r square should be considered. I is the moment of inertia of that particular body, whether it may be a sphere, whether it may be a rod, or whether it may be a cylinder. So we have to consider the moment of inertia of that cylinder or spherical ring or whatever the solid object is given there. So v is equal to under root of 2 mg h or under root of 2 mg l sin theta by m plus I by r square. Now 25th one revolution is equal to 2 pi radians. One revolution is equal to 2 pi radians, or 1 radian is equal to, bring the 2 pi to denominator of the left side, 1 revolution by 2 pi. 1 revolution in a circle is theta, full circle is theta into 2 pi. So 1 radian is equal to theta by 2 pi, or 1 revolution by 2 pi. 1 revolution is equal to 2 pi radians. So we know that in the case of that omega is equal to, we will write it as formula number 19. If you just observe that omega is equal to 2 pi n. N means revolutions per second. You should consider for revolutions per second. Minute means by 60 you have to divide again. to 27th one, momentum is equal to yes, familiar formula, mass into velocity. Yeah, velocity is equal to linear velocity is equal to r into omega, radius into angular velocity. So P can also be written as P is equal to m into V. P can also be written as P is equal to m into r into omega. Okay, so with this we have completed the entire chapter. These formulas you should get thorough with that, then only you can solve any problem. So if you wanted to do any problem, first you should have total formulas in the graph, then only you can able to complete the problem. Okay, thank you children being with us. Have a nice day. Don't miss the formulas, read well.